All right, guys, we are finished with chapter 5, and I'm going to spend a whole time on review. And this video might get pretty long because I want to cover a lot of stuff. But I will, even though it might be long, I will be going very fast, or what I think might be a little fast. So if you need to pause, take notes, this is more for your guys' benefit than anything else. So yeah, let's get right into it. So what was the main thing we learned about in chapter 5 is what I would ask you if you were in a live classroom, but you're not. So I will just kind of give it away. And trig, right? That's all that this section has been about. It's been about sine, cosine, tangent, and then what went with that. Cosecant was the reciprocal. Secant was the reciprocal of cosine and cotangent. And then we also had finding inverses, right? We had inverses when we wanted to find angles. And we had reference angles were a big, everything revolves around reference angles, right? You know, we had the law of sines, Pythagorean theorem, law of cosines, all of this type of stuff, right? But it all revolved around trigonometry. We had the unit circle to help us with that, and other things like that. And so here is essentially a review page, and I will post this as a material. I will scroll through it in case you want to write it down, because when I do print it out, it gets kind of small, so it might be kind of hard to read. But you could always reference this video, or you could write it down yourself. Some of the big things that you really want to use on Delta Math, but it's good to know, that was the degree and minute and seconds conversions were really good to help with book problems. But as we go down, reference angles, again, huge. I'm not going to go through everything in detail until it comes up in a problem. But reference angles are huge because that's when sine, cosine, and tangent, their reference angles are all the same. The reference angle is essentially just what's closest to the x-axis, what's acute to the x-axis. So everything's built around reference angles. ASTC is huge. This tells you where a trig function is positive, right? A stands for all of our positive first, then sine, then tangent, then cosine. That's where they're positive, which helps you in finding angles. And we have the trig ratios, right? SOHCAHTOA, big one. I think we're all pretty comfortable with SOHCAHTOA. The next important thing is remembering that cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. A lot of people mix up the secant and cosecant because they want to put cosecant with cosine, because that's kind of like what seems natural, but it's actually the other way around. And so it's important to remember that. And it also is also important to remember it depends on the angle you are talking about, which side is opposite and adjacent. And sometimes only for right triangles. These are big. These are huge. If you don't have these, use these triangles and the unit circle to find angles and reference angles. These are massive. If you don't have these written down, I would pause this video and I would write these down right now. Even if you're like, I'm going to print out that one sheet, I'm just going to look at the one sheet. I would print this. I would draw this down. This is a huge help in finding angles. And then we do have to get comfortable with our unit circle. And this here is something we also have to know about our unit circle, right? So that just, this stuff on the right comes from the unit circle with radius 1. So right, x is cosine of theta, because if we took the cosine of this angle here, adjacent would be x, and then the hypotenuse would be 1. So x over 1 is just x. So that's our unit circle. It helps us find some angles if we remember from the beginning. And then before I get ahead of myself, just at the bottom here, sine inverse is asking like whose angle is the sine ratio, whatever. In this case, we have 1/2. And then law of sines and law of cosines, you guys should have that written down somewhere. And let's just get straight into the example. So find the exact value of tangent A in simplest radical form. So these are all straight from Delta Math. It's going to look very similar to how your test looks. So I would really pay attention to every detail I do in all of these. So the exact value of tangent A in simplest radical form, aka we can't use our calculators because we have to leave stuff in radicals. First of all, tangent A. So we're looking at angle A. Tangent is opposite over adjacent, which is 3. And you might be like, oh, hey, I'm done. You're actually not, because the square root of 72, it wants it in simplest radical form. The square root of 72 is the same thing as 2 times 36. And that 36 can actually come out as a 6, right? The square root of 36 is 6. So you're going to have 6 square root of 2. And so then we have 6 square root of 2 all over 3. 6 divided by 3 is 2. So we actually have 2 square roots of 2. And that's our answer, right? That's simplest radical form. Yeah. So now find the exact value of cosine of A in simplest radical form. So we're looking at, was I looking at the right angle up here? It's at A, yep. So we're looking at A again, luckily enough. Be careful though. If it tells you you're looking at B, then you have to be looking up at B, right? So cosine of A in simplest radical form, cosine is SOHCAHTOA, adjacent over hypotenuse. So that's 6 over the square root of 37. Right. And then from there we have, it says simplest radical form. So we need to get rid of that square root of 37. And we multiply the top and bottom by the square root of 37. 6 times the square root of 37. The square root of 37, nothing nice comes out of that like the previous one. And then on the bottom, we just have 37. And so that's what Delta Math is going to want. Next one. And blah, blah, blah. This is, the question is, what ratio represents the cosecant of y? So now, pay attention, we're up here looking at y, right? It depends which one we're looking at. Cosecant goes with sine, right? So let's find the sine of y. The sine of y is going to be opposite over hypotenuse, so OH. So opposite is 80, hypotenuse is 89. And then the cosecant is just going to flip that, right? 1 divided by 80 divided by 89, dividing by a fraction is multiplying by the reciprocal. So the cosecant of y equals 80 over 80, or oops, 89 over 80. All right, and that'll be your answer. And triangle STU, blah, blah, blah. What ratio represents the tangent of S? So now we're looking at S. And tangent is simply just TOA opposite over adjacent. So 80 over 39, right? Opposite and then adjacent. And technically that would be the tangent of S. But that would be what you put into Delta Math. So given cosine of A is 6 over 6 square root of 61, and that angle A is in quadrant 1. Okay, so we know we're in quadrant 1, so we can kind of just make a triangle as if we're in quadrant 1, right? Because if we were on a graph, quadrant 1 would be here, and that's why we would make the triangle like that. So with that said, we know that the cosine, I'm just going to say that this is A, right? The cosine of A is adjacent, right? Cosine is going to be adjacent over hypotenuse. So, adjacent. So, adjacent to A is going to be 6, and the hypotenuse is going to be the square root of 61. And then it wants cosecant, which goes with sine, and to find the sine, we're going to need to find the opposite side. So Pythagorean theorem, right? Pythagorean theorem says that this side, I'll call it little a. So a equals the square root of the square root of 61 squared, which is just going to be 61 minus 6 squared, which is 36, Pythagorean theorem. And that is going to be the square root of 25, which is just 5. So now we have a equals 5, and now we can find the sine of a. The sine of a equals opposite 5 all over the square root of 61, and I wouldn't bother rationalizing yet because, again, we're looking for cosecant of a, and cosecant of a is just going to be those flipped, right? Because cosecant is the inverse of sine, or the reciprocal of sine. So we actually have the square root of 61 over 5, and that'll be what you put into delta math. All right, if theta is an angle in standard position and its terminal side passes through the point 98, what is the exact value of secant of theta? So when I see this, I'm given a 0.98, I'm just going to graph it, right? 9/8 is maybe like that. And I just like to make a triangle. 9/8 happens to be in the first quadrant, right? So positive 9 in the x and positive 8 in the y, right? But if it was negative 9/8, right, this would be like negative 9/8. And if we had it down here, that would be negative 9 and negative 8, right? So it all depends on where you are at. But we are focused on this one. So after I've made that triangle, let me just zoom in on it, pretend that the quadrants right there. We have 9 and 8. And find the exact value of secant theta. So secant, we're going to deal with cosine, so we're going to need that hypotenuse. So we're going to need to do 9 squared plus 8 squared. Which is the square root of 145. And I don't think that has any nice square roots. So we're just going to leave it like that. It doesn't simplify any further. Square root of 145. And again, same thing now. We're dealing with, we want secant. So to do secant, we're going to need cosine. So, and this would be our theta, our angle theta, just like it would be here. So cosine of theta equals adjacent, which is 9 over the square root of 145. And I'm not going to rationalize yet because I don't have the answer I want. And I actually want secant, so I'm just going to flip that, right? So secant of theta equals the square root of 145 over 9. And that's as simplified as it gets, and that's how delta math is going to want it. So find all angles 0 degrees to 360 degrees that solve the following equation. Cosine of theta equals 1. And this is where I would initially be like, you should look at your triangles. But 1 doesn't really come up in any of our triangles besides a special case of tangent with 45 degrees. So kind of if you see 0 or 1, more often than not, you should probably be looking at your unit circle. And I'll go over the exception after this. But if we have a unit circle, remember we have a point xy on here where x equals cosine of theta and y equals the sine of theta. And then We also have, I'll squeeze it in here, we have tangent, I'll write it over here. Then we have y over x equals the tangent of theta. And that comes from the little triangle we made, right? If it's a unit circle, that's 1, and that's theta. And this is x and y. So the cosine would be x over 1 or just x, and the sine would be y over 1 or just sine. So that's why they're interchangeable. Now, cosine of theta equals 1. That's essentially asking where is this x value equal to 1? Well, only in one spot, right? Right here. That's the only place where x would be 1, right? Here it's -1, here it's 0, and here it's 0. So the only place is going to be right here, which that angle is 0 degrees, right? And that's our only answer. A lot of times we have 2 answers, but in this specific case, it's only 0. And so here's the exception, right? I said if you see a 0 or 1, you're probably not going to use those 30, 60, 90 triangles. But tangent is the exception, and I'll show you why. So tangent, when you see -1 for tangent, you're actually going to make a 45, 45, 90. And I have to calibrate the board real quick because it just went a little wonky. So I said tangent is that exception, and that's because we have that ratio square root 2, square root 2, and 2. So why is 1 the exception when it comes to tangent? And that's because if we look at 45, if we look at this angle, 45 degrees, tangent is opposite over adjacent. So let's look at, so tangent of 45 degrees is opposite over adjacent, which is square root 2 over the square root 2. So isn't this tangent to 45 degrees equal to 1? So 1 is our reference angle. So, or sorry, 45 degrees is our reference angle. But notice that we're not finding the tangent of 1, we're finding the tangent of -1. So this is where we use ASTC. ASTC. And so I know that it has to be negative. So where is the tangent negative? And that'll be right in the second and fourth quadrant. So I know, and my reference angle is 45 degrees. So in both, that's going to look like that. And both of those reference angles are going to be 45 degrees, right? They're closest to the x-axis. And so the actual angles that this is, right, is going to be, you can think 180 minus 45 or 90 plus this, which happens to be 45. So it's going to be 135 degrees, right? And then you can think all the way around. Let's do red now. Let's do red all the way around is going to be 360 minus 45 or 270 plus 45, and that will be 315. And so those will be the 2 answers that Delta Math will want. And here we have find all angles, same sort of stuff, right? I'm going to ignore this negative at first, and I'm going to think square root 3 over 2. Well, square root 3 over 2, that reminds me of my 30, 60, 90s. Across from the 30 is the smallest side, 1. Across from 60 is the second, which is square root of 3. and across from my hypotenuse is 2. And so what is our reference angle? So I'm going to do theta, and I'm going to do a little r for reference. And notice cosine, the only way that we get square root of 3 over 2 is if it's 30, right? Because then adjacent is that square root of 3, and hypotenuse is that 2. So we know that that is 30 degrees from that triangle. But again, we have to do ASTC. And we have to find, notice it's negative again, so we have to find where it's negative. Cosine is negative in these two quadrants. And so when I sketch my reference angles, I know that they need to both be 30 degrees. Both of these are 30 degrees. And so all the way around here, I'm going to go 180 degrees and then take away 30, or 150 degrees. And then if I go all the way around here, I'm going to go 180 degrees plus another 30 degrees, or 210 degrees. All right, and those will be the two answers that Delta Math will want. So in this triangle, blah, 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 find the length of u to the nearest centimeter. So here, I always want to sketch the triangle. I see T is 58 degrees, so I know I'm going to have some acute angle. I don't know exactly what it's going to look like, but let's just sketch it. This one's pretty small, and that angle I intentionally made was T, which is 58 degrees. And U is 68. Let's do this one because this one looks like the next biggest that I randomly made. So U, and little u will be across, little t will be across. I should make this u bigger. And S was our other one, so S and S. And we're going to find the length of u. So we're looking for u. This is law of sines, right? So u over the sine of, it gives us 68 degrees equals, and then just pick another side I know. It gives me that S is 36. So that little length there is 36. So that'll be 36 divided by, and then the sine of, we don't have what S is, but we can easily find it, right? 180 minus 68 minus 58 will be 54 degrees. And then U equals 36, multiply that sine of 68 degrees over, all over the sine of 54 degrees. And that's just a plug and chug in the calculator. 36 times sine of 68 divided by the sine of 54. And we're going to get that it's about 41.3. And then it says, the question asked to the nearest centimeter. So that would actually just be 41 centimeters, right? And Delta Math just wants the 41 to the nearest whole centimeter. Yep. So last one here, and triangle OPQ. Do I see any angles? I do see an angle, so I'm just going to try and kind of maybe make a 37-degree angle. I don't know what the rest of the triangle is going to look like. Doesn't matter too much. 37 degrees. That's Q. So across from, we're going to have little q. O is going to be the longer one, so let me make this O, which is 9.2. And let me, so that means that has to be O. This has to be big P. And across from that is going to be 2.4. Little p. Find the length of Q. So to the nearest tenth of a centimeter. Again, this is one where I look at it and I'm like, oh, let me use the law of sines. Well, the law of sines won't work, right? Because we'll get Q over the sine of 37 degrees oh, but then we don't really have another way to find that angle. So this is where law of cosines is going to have to come in. And we're going to have to say q squared equals the other two sides, 9.2 squared plus 2.4 squared, minus 2 times the other side's 9.2 times 2.4 times the cosine of the angle across from it, which it's nicely given to us as 37 degrees. And this is just plug and chug, right? Square root both sides, and you will get Q equals, let me crunch these numbers, 9.2 squared plus 2.4 squared minus 2 times 9.2 times 2.4 times cosine of 37. Be really careful with your parentheses here, guys. And then the square root of that. Which is going to be about 7, and then it asks to the nearest tenth of a centimeter, so 10.4. That's what delta math will be for. And I believe that wraps up. Yes, it does. That wraps up Chapter 5 in the Chapter 5 review. If you have any questions, please ask before your test.